Now, after you have drawn that, you are going to, what I meant with complete transfer of electrons is that this sodium has got 1 electron here, while chlorine has got 7 electrons. So what you are going to do, sodium is going to lose this electron here. After that electron has been lost, this electron is going to be transferred to this chlorine. The electron is going to be lost and completely transferred to this sodium here. Sorry, chlorine here. So what we are going to remain, we are going to have in turn, this energy level is going to be removed. So we are going to remain with 2 energy levels. After losing this electron, the energy, the uttermost energy level is going to go away. So we are going to remain with 2 energy levels. One. Now, so sodium ion, then we are going to remain with sodium ion, which is sodium ion. Then, since we've lost this electron, we're going to 8. Then, chlorine is also going to gain that electron. After chlorine has gained that electron, then we are going to have this electron being transferred here. And it comes here. Then chlorine will have 3 energy levels. Now, if we look at chlorine, there's that electron which has been lost from sodium and gained by chlorine, and it's going to be represented by X, showing that this electron does not belong to chlorine. It has been gained from sodium, therefore it is going to be represented by X. That's why if you choose to use this one as dots, the dots you are going to use for chlorine. Why? For sodium, you are going to use the X. But the electron that has been gained, you are going to use X here. So we are going to do more and more example. Now, continuing. Sodium atom reacts by losing its single valence electron to chlorine atom, which I already explained. Resulting sodium ion will have 10 electrons and 11 protons. That is why you are going to write sodium as Na positive, because we are having a net positive charge. Chlorine accepts the electron created by sodium, the atom's energy level. Resulting chloride ion will have 18 electrons and 17 protons. Thus, you have a net negative charge. So, sodium with a net positive charge and chloride ion with a net negative charge will mutually attract each other, leading to what we call an ionic bond. And we find that this ionic bond is being held by a certain kind of force called electrostatic force. The force that holds this type of bond is called electrostatic force. An bond therefore formed when there is complete transfer of valence electron from one atom to another, resulting into 2 ions with opposite charge. Therefore, generally, the reaction between metals and non-metals result in formation of ionic compounds. As I will explain. Examples of other ionic compounds include potassium fluoride, magnesium oxide, magnesium chloride. So let me just draw these ones. So potassium has got 281, 2881. 288. 2881 plus fluorine 27. Now this is potassium K2881 while fluorine is 27. Now this fluoride ion, this electron will be transferred to this post or that point. And when that happens, this complete transfer, the outermost energy level will go. After the outermost energy level is gone, then we can have 2H so this is 2H8. Then chloride ion is potassium positive. Chloride ion will be 2H2. Such that there's a complete transfer of this electron to here. So you find that chloride ion is fluorine, fluoride atom need one electron to be stable, while this one needs to lose one to be stable. Another example which is not here, which I can also use, let us see about lithium fluoride. Lithium is 2,1. So lithium is 2,1. Let us look at lithium 2,1. Lithium is 2,1. 1, 2. Plus fluorine, which is 2,7. 2. Now, for lithium to be stable, lithium 2,1, then fluorine is 2,7. Now, for lithium to be stable, it needs to lose one electron. While for fluorine to be stable, it needs to gain one electron. So, this lithium is going to lose this electron to come here. Such that once it loses this electron, it's going to remain with 2,1. Lithium is going to remain with 2 solid plus. Then here fluorine is going to gain that electron to come into this structure to give 2,7, 2H, sorry, 2H. Negative. So this one positive, remove 2, this one will be fluoride negative, to remove 2. Or with that X represent another example. Let us see an example that involved 2 electrons to be lost. Let's see an example. Beryllium oxide. Beryllium oxide. So beryllium is 2,2 plus oxygen is 2,6. Now beryllium is 2,2, beryllium, while oxygen is 2,6. Now beryllium needs to lose 2 electrons in order for it to be stable, gaining that one of helium, stability of helium. While oxygen needs to gain 2 electrons in order for them to be stable, in order for it to be stable. So what's happening? These these 2 electrons will be lost and will be gained by oxygen. The 2 electrons will be lost and gained by oxygen, and when that happens, we are going to lose the outermost electron, the outermost energy level. So we are going to have beryllium, having that one here. And since there was 2, we have 2 there. So beryllium is 2, and we have 2. Now, this oxygen atom here is going to gain the 2 electrons that have been donated by beryllium to become 2H. Now, so this oxygen, O2, going to be 2H. Looking at this one, the 2 electrons which have been gained from beryllium, this electron here. So we are going to stop there, and next time we are going to continue with more examples in ionic bonds, so that we see how it goes. So thank you.